Up, calculus students. Lesson 2, more antiderivatives. Talk about how the antiderivative of e to the x is e to the x, since the derivative of e to the x is e to the x. We talk about how the antiderivative of 1 over x, the power rule doesn't work. Power rule doesn't work for a negative first power. The power rule works for every power except a negative first power. If this was 1 over x squared, we could use the power rule. But 1 over x, power rule doesn't work. It gets to like an x to the 0. You got to remember it's log absolute x. Absolute x so that like we can plug in any x, assuming that we could plug in any x here. If we are talking about x's that are just bigger than 0, then we'd be able to just have the regular log function because you're only allowed to plug in positive values into the log function. And then we got into a simple undoing of the chain rule, which involved a linear function being inside of another function, how you could take the antiderivative of the outer function, just like with Vegas, with derivatives, it goes the other way. What starts in the parentheses stays in the parentheses. But then understanding our chain rule, knowing that we would have an A coming out if we use an O and an I, we know we have to undo that, that constant that'll come out. So we have that. And that's the lesson. So, oops. So let's just get to it. This is a good example where you can use the power rule. You can use the power rule. You can't use the power rule. I always recommend always rewriting it as negative powers. Whenever you have a negative first power, no, you can't use the power rule. It doesn't work. So for the negative third power, use the power rule. Add 1, multiply by the reciprocal, worry about the coefficients after you worry about the power. And then when you get the negative first power, you just got to remember the derivative of log is 1 over x. So if I wanted to write this a little bit nicer, I could do that and that. Cool. Starting with our first undoing of the chain rule. I would take the antiderivative of e to the power. The antiderivative of e to the power, we're going to say, is e to the power, so long as it's simple. We'll see that it's a little bit more complicated if it was not linear. If it's not linear, things are not going to work out nicely, and you'll see. And then we will have the undoing of the derivative of this. Okay, we're undoing things. So I have the e to the x over 3. I need to undo the derivative of this. The derivative of this is a 1/3, which is why I need a 3. I have e to the 4x, that's the antiderivative of e to the x kind of. But then I know the derivative of the 4x is going to be a 4. This is why I need a 1/4. Now this is a good one. This shows up on your test. E is just a number. The antiderivative of just e is ex. It's not e. It's not e to the x. E to the x is a function whose antiderivative and derivative is e to the x. E is just a number. Okay, so don't get confused by that. What do we do if we handle some coefficients? Well, just like we did with the power rule, we start by rewriting it correctly. That don't move the 5 up. It stays as 1/5 x to the negative first. The power rule works for every power except the negative first power. If you have a constant in front, you leave it. You like worry about it afterwards. Well, I have no other coefficients to worry about because you don't have any composition, so I just have that. Same with that. I could combine the amount of log x's if I wanted to, but like not that big of a deal. I could have combined the amount of x's I had here too, but I don't want you to do that. Simple undoing of the chain rule. e to the x is the antiderivative of e to the x. It's a linear function. The derivative of 3x is just 3. I need a 1/3. The antiderivative of cosine is sine. I'm going to leave what starts in the parentheses. I have this 2 in front. The derivative of the inside is a 4. I need to undo that 4 with a 1/4. The outside is the 4th power. I'm going to take the antiderivative of the 4th power. I can do this since I have a simple linear function on the inside. What starts in the parentheses stays in the parentheses, and then we have a 1/5. You're probably wondering, like, when can't you do this? I think we had an example in our lesson like this one here, where we can't do it. And so, like, when we get to this problem, see why undoing the outs, or see why trying to do this with the whole antiderivative of the outside and then undo the derivative of the inside doesn't work like we want it to. Okay, so heads up, this one is probably the most important one, where it's like this is not linear, and we're going to figure out why it doesn't work. All right, so to make this look nicer, I have 1/30 to the 3x. I have 1/2 sine 4x. I have 1/25 5x plus 2 to the 5th. You can double check by taking the derivative. Okay, I had the 3 and the 1/3. Okay, great. I'll have a 4, which, boom, 2. The 5 will come down, and a 5 will come out of here's the derivative of the inside, so that'll get rid of the 1. Great. Okay. Whenever I have stuff, it might be advantageous to rewrite it as the stuff to the negative first power. This will go for anything in a denominator, is to rewrite it as a power in a numerator, as long as there's x's. Make sure you know, classic math. 1/2x plus 3 is not the same as 1/2x plus 1/3. Think about that. You would need a common denominator. It would not end up being 1/2x plus 3. So don't try to do that. It does not simplify like that. So little star here. Does not equal. So what do? We see it's a negative first power. The antiderivative of the outside would be the log absolute. What starts on the inside stays on the inside. We know that if we took the derivative of this, we'd have a 2. This is why I need a 1/2. We got a log. I have a 4. It stays the 4, but I know the derivative of the inside is going to be a -1, which is why I need a negative in front of that. Okay. There are log properties. Where the log of a times b is the same as the log of a plus the log of b. This is very much like exponent rules. I don't see this on the AB test. It shows up on the BC test, knowing to simplify using your log properties. So what is this like? This is like x squared times x cubed equals x to the 2 plus 3. See how it's like exponent rules, logarithmic rules go hand in hand? Another rule is a log b equals log of b to the a. This is very much like x squared cubed. It actually goes the other way. X squared cubed is the same as x to the 2 times 3. You see this multiplication here. You see the power to the power here. So keeping that in mind, I'm actually going to rewrite this. So that's 1 log. I've log 2x plus 3 to the 1/2. I brought the 1/2 up. I can bring the -4 up if I wanted to. Or I could say it's subtracting. Addition means multiply into 1 log. And then the negative power goes to the bottom. So I could rewrite this as log absolute 2x plus 3 to the 1/2 over absolute 5 minus x to the 4th. Cool. And it ends up like the absolute values go with these quantities. For you guys, this is fine. This may possibly be on the AP test, but most likely it's usually on the BC test. Find f given f prime, so we're just going backwards to your original, which is the whole purpose of this semester, is going backwards. If you have how quickly something's changing, could you get the original thing? It's like, okay, yeah, it seems easy until it isn't. Antiderivative of cosine is sine. 2, but I need to undo the derivative of the inside. I have a 1/6. So there's that. Going to start out for this one by rewriting everything using negative powers. Going to remember that the power rule works for every power except for negative first power. I'm going to say that over and over and over again so that you don't make the mistake that so many students make, which is taking this and thinking that the antiderivative is log. It's not. The only antiderivative that involves a natural log is the antiderivative of the negative first power. All right, now we will have a log absolute 4 minus 3x. We will undo the derivative of the minus 3x to give me a negative 1/3. I will have the antiderivative of the negative second power, which is a negative first and a negative. And I got to undo the derivative of the inside, which is why I have a negative 1/2. I will antiderive the negative third power, leave the 4. I have a negative second power and a negative 1/2. And I will undo the derivative of the inside, making us having another negative. This is probably the one that most students are going to make mistakes on because of like all of the undoing, all of the anti-deriving. I'm going to use a minus. Attribute that to, since this is just a first power. There we go. It just went backwards. All right. Now we get to the problem of the day, which is something that you always have to worry about. Watch. If, careful, heads up. I hope you're watching the video, or I hope you're skipping to this one. I hope you realize you're going to get this wrong. If you take the antiderivative of the outside, and then you undo the derivative of the inside, you're probably thinking you get this. Well, what's the problem with this? Why is this not the derivative? Or why is this not the antiderivative of that? Because if you took the derivative of this, it's going to be a quotient rule, and it's not going to cancel out nicely. This is not correct. This is an example of something where you have to simplify. We will eventually get to things where it's like you just can't. It's like either takes too long or we just won't be able to do it. We'll have to talk about how do we go backwards if we can't take the antiderivative. It's a big part of the second semester. How can we go backwards if we can't take the antiderivative? To be able to take the antiderivative of this, you have to simplify. That's x cubed plus 2 times x cubed plus 2. That's x to the 6 plus, sorry, x cubed plus 3 times x cubed plus 3. It's x to the 6 plus 6, x cubed plus 9. If you need to write it out and distribute it all or use the box, whatever, do that. 1/4 and 6 simplifies to 3/2, 9x plus c. This is the answer, not that. Go ahead, and if you have time, check. Like, use the product rule or use the quotient rule. You're not going to have things cancel out, and it's going to work out because of our knowledge of the product rule and the quotient rule. However, this does work. This is just 3x plus 4. This is linear. We won't have x's that come onto the outside. We will be able to antiderive the outside and undo the derivative of the inside because the derivative of the inside is just going to be a constant. It's not going to have x's. So we won't have anything crazy show up. Okay, cool. Antiderive the outside. The derivative of x over 3, which is the derivative of 1/3 x, is just 1/3. I need to undo that with a 3. These cause a lot of problems for a lot of students. This one is 1/3 e to the 3x. Going to keep the 1/3. I'm going to take the antiderivative of e to the power, which is e to the power. I have the derivative of the inside, which is a 3 that I need to undo with a 1/3. For the last one, all you have to remember, which I didn't really test you on, but let's go back to the derivative of e to the x. We could have said the derivative of e to the x was e to the x times the natural log of e. Why don't we include the natural log of e? Well, because it's 1. So it just goes away, which is why we say the derivative of e to the x is just e to the x. But if it's any other number to the x power, the derivative is that number to the x times the natural log of the number. Okay. Now, what happens when we go backwards? Well, this is like a number. It's a constant, this 2 that pops up. It's almost like if you take the derivative of e to the 3x, you know it's going to be 3 times e to the 3x. This is the derivative, which means if you were going to take the antiderivative, you need a 1/3 to undo the derivative of the 3. It's confusing. Like, when do we need a 3? When do we not need a? When do we need a 1/3? You will have to keep track in your brains of like when we're taking derivatives, you need the derivative. When you are anti-deriving, you are undoing derivatives. Okay? Because of that, this constant log 2 needs to be undone. Which is why I need a 1 over log 2. It's like undoing the constant that comes in front. 3 to the x, antiderivative is 3 to the x. The derivative of 3 to the x is 3 to the x log 3 being a number. I need to undo that number with a 1 over log 3. The derivative of 4 to the x is 4 to the x times the natural log of 4. I need to undo the natural log of 4 if I'm going backwards. All right. We got 2 pages of differential equations. All this means is like find your C's. You're given a piece of information that helps you go backwards to find the specific function, not just like a general function. So leave the constant. Antiderive stays the same. Undo the derivative of the 3x minus 6. Combine. F of 2 equals 4. That's 4/3 e to the 0 plus 4 plus c equals 4. E to 0 is 1. 4/3 plus 12/3 plus c equals 12/3. So c is equal to negative 4/3. C turns into negative 4/3. Okay. It's a good one, simple one. Antiderived cosine. Sine's derivative is positive cosine, so I need sine. I know the derivative of the inside is going to be a 1/2. I need to undo that with a 2. Keep in mind, we're going backwards. We're undoing things. We have f of pi equals 3. Sine of pi over 2 straight up and down. Vertical distance is 1. So 2 plus c equals 3, c equals 1. Okay. I'm going to start, before I take the antiderivative, by rewriting this as a negative first power. I'm going to remember the power rule does not work for a negative first power. So I leave the constant, take the antiderivative of the negative first power, worry about undoing the derivative of the inside, and all of a sudden I have a negative 4 because of that negative coming out. I have a plus c. This is just f. I've taken the antiderivative. F of 2 equals negative 4 log 1. The natural log of 1 is 0. You need to remember 1 is e to the 0. So c equals negative 2. F of 3 minus e equals 5. Very interesting. Same deal though, I'm going to have the same antiderivative. So I already know I have that. F of 3 minus e. Now here's the key, which I know a lot of you will make a mistake on. It's a classic mistake. You're subtracting 3 minus e. Now it actually doesn't matter because of the absolute value, but watch. That'll be minus a 3 plus an e. So it becomes log e plus c. The natural log of e is 1. So negative 4 plus c equals 5, which means c is 9. And we have f of x is negative 4 log 3 minus x plus 5 plus 9. Every time we antiderive, we're going to have to undo that derivative of the inside. Here I have a second derivative, so I need to go back twice. I have 2 pieces of information. I'm asking you to find f of 1, finding the missing value. These ask you to just find f of x. So the antiderivative of e to the x over 2 will be e to the x over 2. The derivative of x over 2 is a half. I need to undo that with a 2. The antiderivative of 2 is 2x. I have a c every time I take a step backwards. F prime of 0 equals 1. E of 0 is 1, so I have 2 plus c equals 1, which means c equals -1. So now I have an f prime is 2e to the x over 2 plus 2x minus 1. I'll go backwards again. I have the e to x over 2. I have the 2. The derivative of x over 2 is a half. I need to undo that with another 2. So I have 4 e to the x over 2. If you're able to do this, great, great. You're in a good spot. If you're able to understand why you're doing it, better / best. That's what we want you to do. It's like to remember going backwards, we're going to have to like undo what happens when we go forwards. Instead of having the constant 1/2 showing up, we need a 2 to undo it. All right. We got an x squared, we got an x, we have another c. We have f of 0 is 2. So I have 4 e to the 0 plus 0 minus 0 plus c equals 2. So that means c will equal, this is 4. I'm going to subtract 4 from both sides, -2. So this becomes a -2. That means f of 1 is going to be a weird looking number, but whatever. 4e to the half plus 1 minus 1 minus 2. So plus 1 minus 1 is 0, minus 2 is -2. So this is my answer. Ooh. Go backwards. The antiderivative of sine is negative cosine. What starts in the parentheses stays in the parentheses. The derivative of the inside is a 3. I don't want the 3, which is why I need a 1/3, and then it'll make a negative 1/3. Don't forget your plus c. F prime of 0 is 2. The cosine of 0 is 1. We'll go with that. I'm still fighting off whatever bug I had last week. I think Tuesday was my worst day. No, I think Wednesday was my worst day. Yeah, Wednesday was my worst day. And then I thought I was feeling better this weekend. Then bam, I just had this headache all day yesterday. I was drinking water and I was being healthy all weekend. And it's just like this thing is hanging around. Hanging around. Oh, go back another step. The negative 1/3 stays. The cosine's antiderivative is positive sine. Sine's derivative is cosine, or negative sine's derivative is negative cosine, so that works. 3x's derivative is 3. I'm going backwards. I need to undo it with a 1/3. So we have our expression for f of x. We have f of 0 is 3. Sine of 0 is 0. So f of 1, c is 3. F of 1 is -1/9 sine 3. No idea what that is. Plus 7/3 plus 3. And we're going to just say, like, there you go. That's free response. Don't simplify. This test coming up will be part multiple choice, part free response. All right, 4 more. All single derivatives. Not bad. This is the best one. Like that. This one I like. You have to take the antiderivative of the outside, which involves a 1/5. But then you know the derivative of the inside is going to have a 2, so you need a 1/2. Negative 29 tenths. Therefore, f of 2 is 1/10 plus negative 29 tenths, which is easy enough to simplify. Negative 28 tenths or negative 2.8. Who? I feel like this is a little bit repetitive. You could skip the rest of these. I won't. I got some feedback that's homework sometimes can be a little repetitive. And it's like, yeah, I see it for this. This is a little repetitive. Skip if you're good. I'll do the rest of them. If you'd like the extra practice, here it is. This is interesting. I need to subtract 1 over ln2 from ln2. If I subtract 1 over ln2 from ln2, I have like the natural log of 2 squared over ln2. Yeah, whatever. Maybe this one works out nicely. Let me just leave it as ln2 minus 1 over ln2. Okay, let's see if this works out nicely. You got 1 over ln2 times 2 plus ln2 to the x plus ln2 minus 1 over ln2. And then I'm trying to find f of 1. So I have 1 over ln2s plus ln2 minus a 1 over ln2, which means I have 1 over ln2 plus ln2. It's like, not, not, not a great problem, honestly. This is a good problem. This is a good one. People get freaked out. Antiderive the sign, you get negative cosine because cosine's derivative is negative sign. Negative cosine's derivative is positive sign. Cool. But you have to undo this. You need a 1 over pi. I turn that negative sign into a fraction bar and I put the negative right there. F of 0 is 4, so I have negative pi cosine of 0 plus c equals 4. C equals 4 plus 1 over pi. That's great. I feel like I plan on this stuff working out, but it doesn't. This becomes pi over 2 plus 4 plus 1 over pi. This is 0, so my answer is just 4 plus 1 over pi. All right, good. Another like kind of easier lesson if you're understanding things. Tricky lesson though. With the trickiest part being how this doesn't work all the time. Trickiest part of this lesson being understanding why this doesn't work. And it only works when it's linear. Trickiest part of the lesson being if I were to take the antiderivative of even like sine x squared, something that seems simple. Let's make it cosine x squared. My computer's bugging out right now. Cosine x squared. I hope this records. I've lost like 2 videos from Canva. Just disappeared. Seems simple enough. It's just cosine x squared. Oh, no big deal. I know how to take the antiderivative of cosine. I know how to take the antiderivative of x squared. But if you say it's sine x squared times 1 over 1/3 x cubed, it's not right. And this is where we have problems. How do we take the antiderivative of cosine x squared? Well, like either we can't or we need another understanding of what could we do. And we're going to start using calculators / Desmos to do it. What could we do to handle the fact that if the rate of change is given to us, how can we go backwards to find y values or positions? How can we find positions if we know how the position's changing and we can't go backwards? So we'll worry about that next unit. Right now, let's just keep going backwards. All right, looks good. Peace.